Good evening, everyone. Hello, good morning. I apologize for being a few minutes late. The stream this afternoon or this evening is going to be about Rust's traits construct. A trait, we're going to be defining what this term means that no other programming language seems to use. We are going to also demonstrate how to use them, as well as actually try and find out what their role is within the Rust programming language, and maybe even kind of delve into some of like how to read the documentation, and because it's actually surprisingly difficult with generics and traits and how that all interacts. And if there's time and if there is willingness or interest, we'll also look at some more advanced stuff. And cool, great. So let's rock on. Here is a code editor. I will just kind of zoom in a bit, or at least try to. Increase the font size, do that again, do that a couple of times. I've got a pretty simple Rust program here. We've got a main function, we're printing out hello world. I'll run cargo run, and then my output is over here. It's hello world. So I can get pretty far with Rust by just defining functions. So I might have a score, and I could take an answer and I'll return like some sort of score. And I got my text, which is, let's just say, string. And ignore for the moment, if you're new to Rust, the difference between like, what the hell is an ampersand stir? And we would just say that the score is a length, or it doesn't implement length. That's not very strange. And then we need, this actually returns a usize, and we need to cast that as I32. So we'll do so. And now we've got our intro. Let's say hello world, or say hello Rust, or something, and then we'll give it a score. And we're just kind of setting the scene a little bit, because now I've got a function that's called the same thing as a variable, which isn't always what you want, but we'll kind of carry on, press ahead, I suppose. I'm going to try and demonstrate that at some stage it gets boring to repeatedly create these functions. And what we really want to do is have some sort of abstraction. So this is a different way inside the editor to run what I've done. Oh, sorry, call cargo run. You can see that the editor has executed it as well as passed in a few other arguments. And we print out hello Rust with our exclamation mark and a score. Is that the IDE? So just had a question. Is that the IDE C-line? Yes, it is. I don't necessarily mean to pump a proprietary product. I would normally use VS Code, but I've been hearing a lot about it, and I thought that I would give it a try. So I'm exploring it as well. So it seems to be, it works fine. And cool. Okay. So, and the question is there one of the questions, is there already a special release just for Rust? And that, no, it's not the case. I'll just kind of change tact slightly, because I've had a question about it. There is a free and open source plugin. If you have any of the C-line products, any of the IntelliJ products, they actually have a Rust plugin. I just happen to use it with C-line, but it works with PyCharm or any of the other ones as well. Cool. Okay. What traits allow us to do? So the first, actually, our first question is like, our first question is like, well, what is a trait? And a trait isn't is the definition of like an abstract interface. Now that isn't very clear. So another way to explain the term trait is to say that it's an abstract base class if you're from an object-oriented language, so maybe Java or C++ or Python, or pick your other object-oriented language. If you are from like a more functional style, or if you're from Java as well, you might just use the term interface directly. A trait allows us to define functions or function signatures, and it's a bit strange. Why is that unhappy? Anonymous function parameters are, so it wants me to give it a name. And now we have this interface, this kind of score thing, which can be implemented by multiple types. And so let's just implement it for, and the other thing that's really cool about traits is that they live independently from your types. And so you can actually annotate or extend types from the standard library. So I could implement score for string. Let's see. I wonder if that will work. And it's going to come up with an error here and saying that I need to implement a method. It's telling me that I need to implement score. And oh, actually, this is going to be a bit strange. Let's change this so that we're actually just referring to self. So we take a reference to self, a read-only reference, and then we return an I32. And for string has a len method as well. And we can implement score. So I'll just change this. There is a distinction in Rust between capital S string and this kind of lowercase ampersand thing. For now, we can skim over that. And I'll show you that I've actually created a method. As long as I fingers crossed, I may have forgotten something. I might rush. Aha. Okay. So we've actually got the same behavior. We have defined an abstract interface, score, and we've been able to implement it for any given type. And what we've actually been able to do is give a type string from the standard library its own new method, score. So that is what a trait is, and it's the start of how to work with them. And so we can implement score for, actually, I'll just pause there. I've seen a couple of questions have popped up. And then apologies. Okay. So I wondered if I had rushed this. So the question is basically, why are we bothering with traits? It sounds like you're actually trying to answer a problem that doesn't exist. Like we had the score method before, a free function, and that was fine. So let me try and maybe answer it a different way. If we wanted to be able to add the ability to, let's say that we had a generic method. So we wanted a function which could have a report, and we wanted to be able to report on any type. We're just going to call this, we'll call it text, because we've got text at the moment, any text T. But we wanted to ensure that the report had some sort of score. So we want to be able to report on type, or any type. And in our instance, what we'll do is we want to say text.score. what we can do with traits is actually encode in our type system that and actually this one will require the debug method as well. Otherwise this print line method won't work. And the traits allow us to kind of parameterize functions, or they kind of work with inside the generics system. So I'll just use standard format debug. And now this will stop complaining. So it's turned green. And I should be able to report on intro. Now I've taken text, and I probably want to take a read-only reference to report. And let's see if this works. We should just see 12. We do. We see 12 as output. So what the original problem that I was attempting to frame was that it can become, like, at some point we want to be able to define an interface. Like say that we want to create a read trait. We want everything that can read from a file to do it in a uniform manner. And traits are an ability to kind of encode what we want. It turns out as well, they become really useful for like generics. If I wanted to, I could implement score for like any integer. Actually, yeah, well, let's just say that we can implement it for i32s, and then I would just return self. Would that work? Mismatch. Oh, I took a reference. So I've got a reference as the argument, and the type system said, actually, you need to dereference self. You need to dereference the argument to get to the return type. And we could implement score for any other kind of type as well. But at this stage, I'll leave it like that. And it means that if I wanted to, I could just put in a number. I wonder if this will work. It's probably going to get grumpy with me because it's compiling, and then I get point at the end 3032. Does that answer the question, Sam? Yeah, hopefully it does. Okay, so where was I? One of the things that I wanted to be able to do was to, so there's an answer to the question as well. With traits, you can define or bring together functionalities that are common across types. Any type that implements a trait has those functionalities. Traits are at the center of the Rust language. So, and I will provide a couple of examples. So to start with, I want all operator overloading is implemented with traits. That is, so if we go to, I'll just change what I'm sharing. Share screen. I think this is what I want. If I go to the Rust web page and find Learn Rust, and I go to the standard library, and I kind of get a little bit confused, running, and then the question is, how do I implement operator overloading? In order to do so, I implement a trait, which is the add trait, and the right-hand side, RHS, right-hand side of the operation must be of the same type. And let's likewise, and in fact, all operators are the same. And there's more functionality with inside inside Rust. So iteration, so iterator. In order for something to be used with a for loop, it needs to implement a type. It turns out that there's two. If your type implements into Iterator, then it can be used with Rust's for loop syntax. And yeah, it turns out that a lot of the syntax that you see in Rust kind of is compiled down to trait implementations. So that's why becoming familiar with a couple of the core traits are really important. Okay, so I'm just checking the comments again. I've had a response from over in Twitch. Another possible way to frame it could be, imagine that you've got various shapes, and you want every shape to have an area method or a function. You could have a shape trait that requires the area function to be defined, and then defined area for each shape that you would like. So square would have a different implementation to triangle. We could actually do so. That might be fun, or it might be boring. People have sort of, so this discussion is, or like this suggestion, I think is quite a good one. So let's say we have trait shape. Now, and we'll have like shape, a 2D shape. A two-dimensional shape has like has some sort of height, and it takes like a reference to itself, returns a float 32. And here's our interface, is that we've got a height and a width. And because we're on the two-dimensional plane, and then we have an area method. We can also parameterize a couple of other things. So we won't bother with that right now. But actually, yeah, we will. Okay, so type scalar, let's say, which is when I get reduced from 2 dimensions down to from 2 dimensions down to 1 dimension. Let's say so these three types can be any single type as long as they're the same. So every implementer of this type gets to choose what they want. We can restrict this slightly by kind of actually adding a trait bound on this type as well, but we won't do so here. I'll try and see if maybe I've made things more complicated than they need to be. I'm probably going to. So I've got a struct here, and it's a shape. It's a square. Now a square has really only one parameter, and so it's got a floating point. So the height equals its width. So F32, and then we say that we want to implement shape 2D for square. Now to do so, we need to define what we mean by scalar. Or are we? Maybe I've got this one wrong. And probably, I'm getting lots of fuzzy. So I need to implement 3 methods. And the first thing I'm going to do is implement. So how height is defined as got this getter function. Width is actually the same because it's a height, and I'm going to do something that is a bit different for area, and that is define a default implementation. And that is going to be that area is defined by default as height times width. Now, I'm probably going to get someone being, it's probably going to be a bit grumpy with me because I've made a slight mistake. And that is, I've just, have I? Let's see. I'm a bit worried that I haven't restricted scalar to be a type that must implement multiplication. And we'll see if that, if this works. I'm not sure if it will. We'll find out soon. So to create a, so I've implemented my 2D square, and I need another block for, in my case, it's going to be a static method. And the static method on square new is going to return type self, which is a way to refer back to the original type. And then I'm just going to, say it's height F32. And this is a different, and height. There's a shorthand syntax that we can use. Oh, that's the only parameter that I need. So this self here is a variable which refers to the square type. We could put both of them in. I could say that this static method returns a square. It's by convention, people don't do that. It means that it's slightly easier to refactor. Well, I don't really know why people don't, but they don't. So now I will create a square, and let's see where we get to. So to call our static method, I've got square new, and I'll give it a height. So let's say 10 or 120. That's a good size. And then I actually want to report. I don't have a report method anymore, so that needs to go. But I can still print things to the screen. I can print line square, and I want area. Now we haven't defined area ourselves inside our implementation block. We're actually trying to fall back to the default implementation. Now I'm curious as to about whether or not I've got this right. I doubt it. No. Okay, so one of the issues is that one of the things that I encounter, which I was worried about. It turns out it was a good reason to be worried, and that is I need to actually restrict scalar to a type which is able to be multiplied. And I am not convinced that I can do this, but I will try. Now, I wonder if that will work. So I'm trying to add this kind of type bound. I think that I've got this wrong. I'm trying to remember, I'm like scratching the back of my memory, trying to find why I've done this. I shouldn't have. Okay. Errors are abound, mismatched types. So self-scalar because of the return type. But I found, okay. So I'm trying to return a, I'm getting myself all into knots. What I'm going to do right now, just for getting this to pass, is actually return the type parameterization. Sorry, remove the type parameterization, and then I'm going to look it up at the end of the stream because I don't remember the exact syntax off the top of my head, and it's going to really annoy me. But that's actually not, it's not material right now. What I want to demonstrate is that we can implement we can fall back to a default implementation for other methods. Okay, great. We've got 14,400, which is exactly what we want. So the area, in whatever, irrespective of the unit, it might be meters, it might be centimeters, it might be kilometers or light years, the area is correct. So that's one cool thing about traits. And you'll find that some standard library traits, and so one of the things that's quite cool is iteration. Iteration only requires you to implement one method, and then you get dozens and dozens of automatic generation, automatic default implementations of other methods. So I really appreciate the iterator trait for that. So okay, cool. Where was I? I was, I think, here. And now, next question is a really good one. Achim has got this problem, and that is, like, how do you find, like, how do you begin, like, where do you start with the standard library traits? So there's dozens and dozens and dozens of them, and it's very begin to understand where you should begin to where you should begin. Like, how do they all fit together? And I'm just going to provide a very brief answer to that, and that is the debug trait right here is very useful. So, so I've got my custom type, and it's a structure which computer, and let's say I always struggle with this. Like, what do you? And let's say it has CPU, hertz, and then it has RAM, like memory, and that's another. So there's not much to. Yeah, okay, it's not the best specification for a computer. Now, one of the very first traits that you'll want to do, or want to learn, is debug and display. Display is next. So we are going to define our computer C, and we've got CPU, hertz, and I'll just say 2.6, and memory. I haven't got a unit, let's say. Oh, it doesn't matter. But let's say that I've got 4 gigabytes of RAM. I was going to say that we can also encode units inside the type system, so we don't necessarily need to use, we can wrap floating point numbers, but I don't want to bother right now. So the problem that you'll face with any custom type is that this print line syntax does not work. So if I click run, and I'll actually do it in the terminal just so that it's a little bit more, if I run cargo run, I get this kind of weird, horrible error message, and it's saying that the trait debug is not implemented for computer. Okay, so the easiest way to do so when you're starting is this derive annotation. Derive instructs the compiler to implement a trait on your behalf. You don't necessarily need to manually create an implementation for you. You don't need to manually do it. It turns out, though, that we can. I can select this text. That's cool. But right now, I'll just comment that out. We don't need to. We don't need to implement it ourselves. Derive will instruct the Rust compiler to automatically implement debug. Now, the problem, well, I say problem, debug can only be implemented if your custom type only uses types which also implements debug. And so if you have, let's say that you have a component, so you've got instruction, you've got RAM, and then you say it's got memory, let's just say gigabytes, and that has F32. And then instead of having memory gigabytes here, you suddenly wanted a RAM struct in there. Derived debug will no longer work. I've just changed this, and my RAM is down here, so I can get all that to compile, or at least I can try. Now, the error that we'll find is that RAM does not implement debug. So what do we do? Well, what we do is we just derive that as well. And then suddenly things work. It's a bit difficult to see, given that you are, there we go. So that will get you quite far when you're starting. The next question is, well, how do I customize the output? I would like to show you display. So the debug trait is designed for debugging output. It is output designed for a human that is who is the programmer, but not it's not intended for users. Now the kind of sister trait of debug is display. And allow me to explain how that is implemented. Display has no default implementation. The first thing that so we need to do it all by ourselves. We've got our, I'm going to leave that one. So the distinction here, by the way, is that I can talk about debug without needing to reference format. Alternatively, with the second line, I could actually create a path that starts at format. And this, right now, we'll just change the, and this is now a problem. So the first thing that we want to do is we want to implement display for computer. We will retain debug for our own purposes. Display for computer. We'll have to ignore for now what this formatter thing is. It turns out that formatter is an internal type to the format module, which we can effectively ignore. Also ignore right now when you're starting what this kind of backtick or this kind of tick and underscore means. This just says, it's a strange annotation for if you're new to Rust, but what it means is the thing that you are printing has a lifetime, and that lifetime must be long enough for the print to actually finish. And the underscore just says that we don't care what it's called. It's just a we say a wildcard. Now for computers, I'm just going to say we can actually describe this in any way that we want to at all. So we're going to say computer, and we'll just say that whenever a computer is displayed to the screen, we actually hide all of its implementation details. I can remove this colon question mark syntax, which requests the debug implementation or the debug trait. And instead, I want to just defer to the display. Now it's telling me it doesn't implement it. I wonder why. I bet it's just because the editor is actually a bit slower. We'll try and see what this does. Okay. Use of undeclared module format. Okay, so there's a problem, and that problem is that over here, I've still got that reference to format, and then I've got this result object which I return. Now I want to, I'm just going to bring it in scope. Computer, there we go. Computer. And that is the very first trait. Well, those are the first two traits that I would implement, or like I would familiarize myself with if I was starting Rust today. What's the next trait? The next trait that I would want to familiarize myself with is iteration. And so now iteration is slightly more complicated. So because because it requires us to have so let's just first we'll just create multiple computers, and I'm going to simplify the code slightly. Yeah, and I want to create a no. I'm going to change my story. Derive debug. I've got my main function, and then I will implement some numbers, and that will be a vector of 1, 2, 3, 4, 5. And so for n in my numbers, print n times 5. So this is so we get 5, 10 through 25. And just the other way of doing it, just if you're doing it manually with the terminal, is to run cargo run, and you get the same result. Now, the reason why it's difficult to start is that there's no indication in the syntax of like which traits are actually important here. It turns out that traits are important, as we've discussed, with multiply. Traits are important with iteration. Traits are also important in terms of the size of each of these elements of the array, and there are various other things in which traits come into play. And so stranded iterator. Iterator is more difficult to do. It's there are two like very important types of traits: into iterator and iterator. Iterator is kind of the core of it, and into iterator is a sort of a helper trait which can allow you to define your own collections. So let's say that I have got a structure which is a random number generator. And I want to implement it has nothing. Why is that wrong? Unexpected. Okay, so it's got no. I'll just maybe we'll put seed and then maybe a U size just for fun. And I want to implement into iterator 4 random numbers, and I should only need to implement next. So there's dozens and dozens of things that I could implement, but the only important method really is this next thing. I also need to define my item. So type item is actually going to be usize. Is it? Yeah, it is going to be usize. So usize is an integer that is the same width of the pointer of the CPU your program is being compiled for. So sum 42. So this will be my random number, 42, every time. And so now I have a different thing. I want my random numbers, and I want to take 5 of them. And let's see if this works. Nope. So take is a method on iterators. Now I've got a couple of expected value. I found a struct. Okay, so I'm going to do this, I think. I wonder why. Where's my editor? Can it help me? Add missing fields. Oh, I need a seed. Okay. And then now the seed we don't even use. There's no reason why I've got it. And then because I implement iterator, actually I'll just do next. Just no. Cool. I get 210, 210, 210, 210, 210. And if you have a good understanding of iteration and printing to the screen, then the majority of simple command line utilities become easier to work with. The next thing I would do after learning about debug, display, and iteration is understanding the distinction between options and results. They are not traits. They are enums defined within the standard library, and they become really helpful to create very robust programs. And one of the things that I could do is option takes is an enum that is either the none variant or sum of type T, and I'll just run return self seed. And just to change things. So this and I'll change the seed to 10. So we should see 50, 50, 50. And one of the things that I could do is say that this particular set of random numbers never, it doesn't have any in it at all, like it's empty. And there's actually nothing printed out here at all. So Achim, I don't know if that has been a good answer to your question. There are more traits to learn as well, but those are kind of that's where I would start, is display, debug, iteration, then probably some of the operator overloading traits as well, and that would probably be a good foundation. Okay. So I've just had a really insightful comment, and that is to the question. I'd say that Rust is a large language in the same way that English is a large language. You don't have to know everything in order for Rust to be useful. I think that's very true. There's no need to memorize everything and all of the built-in traits. But I encourage you strongly, by the way, we're at the point in the stream, well, as you can tell by the fact that I'm answering questions, when you are more than welcome to ask your own questions. And so if you are if you're on YouTube or Twitch, just answer a question in the comments, and I'll pull it out and we'll see if I can answer it right away. There is one other thing that I would like to show you before I go, if there's no other questions, and that is how to read the documentation. And this sounds ridiculously basic, but actually surprisingly difficult. So I have with me the iteration documentation, but I'll find some other trait. So let's, I'll start with a type. So the first thing that I want to do is, I'll start with a type. So let's say that I have a path. Now a path represents a file, and it's going to say our definition is this kind of confusing thing if you have started, which is it is a slice of path akin to a stir. So that's not especially helpful. It turns out that Rust is very particular about type safety, and it is not the same as a regular string. It does not require regular strings in Rust are required to be UTF-8 encoded, and with a file system path, the separator is semantically very different than other characters. Okay, so the question becomes, what methods have I got on this thing? And what can I do with a path? And the way to find this out is to look at implementations. So this implementations term, an implementations term is the equivalent to a native method. So for example, previously in the stream, I implemented new for a couple of my types. It turns out that I've also a path is restricted to types that implement themselves as OS stir, which means that they're not required to be UTF-8 encoded. And what this question mark sized thing means is that the S is not required to have a fixed size. Now, I'll ignore all of that because normally you are not interested. You normally have a fair understanding about your specific types methods. But what becomes really confusing is all of this stuff down the bottom. What does it implement? And why is this important? Because these are all the implementations that are added by default because your type happens to implement, in this case, partial equality. Now, to me, I understand what's happening here, and that is partial equality is the trait that supports the equals sign. There's a so we're like the double equals operator, and so what we're saying is that if you implement partial equality, you can compare books in this case. Now over here if we've got partial equality, paths can be equal to an OS string, or path buffers can be implemented. What this is saying is your path object could actually compare equal to things that are internally represented differently. We've got OS strings in here. There's a lot of things that you can use double equals for. Now, the other thing that I really want to demonstrate is that your type can actually implement methods that it doesn't implement and this becomes really crazy. I'm going to show you what I mean. And Rust has got one element of what I would call magical control flow. And that is with the Driff. I'm going to blow this up. Special. So we're going to be talking about a specific trait which is different to all of the rest, and it's because it adds just this little bit of magic to it's sprinkled around everywhere. Now it enables your type to masquerade as another type. So for example, string, we ignore all of this. We want to find its methods. What you'll see is that string does not have a toUpperCase method. But I'm just going to use the playground for this because it's in the same browser. So I'm just going to change something. And this is something that confused me greatly when I started with Rust. Text. Hello world. Now, like if you look over in string, and it probably isn't going to be this method. It's probably toUpper. But there's no toUpperCase. But and if you already know Rust, this don't release spoilers. I mean, I already have got a spoiler because I've got this Driff trait thing is right there in front of you. Now, what the heck? Let's try and figure this out. Okay, so it doesn't matter where we look, we will never find the toUpperCase method. Oh. How embarrassing. Tricky. Okay. No matter where we look, apparently we will not find toUpperCase, except where it's exactly where it should be now. And it is not a method of string, the string type itself. It is a method of a stir, which is a string slice, and the reason why this works is the Driff trait enables your trait. Driff is a trait that enables your type to convert itself into another type and then call its methods on yourself. And so I wonder what happened if I go into the source. We've got toUpperCase for string. So that if you look at the file, we're in str.rs. We're actually not in. So we're actually inside the stir module. We're not inside string. We return a string, but that's because we require a new allocation and a brand new string. But actually, this is part of stir. And so just embarrassed myself then, but hopefully not too badly. This is why you never do things live. Okay, so the reason why it is really special is that normally Driff is explicit. That is, we have the star v, or for a star, and v here stands for value. But actually, Driff is also used implicitly by the compiler in many circumstances. This mechanism is called Driff coercion, which means that the dereference operation coerces to another type. You'll see here that the self.target type is not required to be the same, is not required to be self. And so in fact, if T implements Driff target U, so string implements Driff into stir, and X is a value of type T, then T here implicitly implements all of the methods of type U. So this is something that's really, really fundamental to how Rust provides a lot of ergonomics, but it also it's really confusing. If you are not, if you are expecting everything to be explicit, because it's not. There is some places where Rust will kind of have this, what I call like magical control flow. In fact, I've picked that up from somewhere else. I think it's from, but I quite like that term. The Driff trait is special. Now, I've just had a really good comment that I'm a little bit scared to answer. In fact, it's been sitting there for a few minutes. And Tim Small asks, if you don't feel like it's too far off topic, I'm finding it really tricky to learn about when to use associated types. So this is going to sound like a complete cop-out, but I don't have a good intuition when I'm defining my own traits. When to use, so what Tim means, what Tim Small means is I've got this other type here, and this is what we call what's referred to as an associated type. And if I'm defining my own traits, when should I use one? When should I not? You'll notice that, well, you might recall if you've been around for most of the stream that I flapped around with my implementation of my area, my shape object, because I wanted to have an associated type that was a scalar value. And now I'm going to, so I'm actually going to ask the rest of the people watching, like, do you have any sense of when an associated type is the right thing to include? Because my sense right now is that it's the kind of thing that if I encounter, I would use, but I'm not going to I'm probably going to derive, I would probably focus on the methods, like the API itself. The reason why you might need an associate, or like, it might be nice if you want to include an associated type inside like a generic type kind of argument or parameter, so that implementers can actually choose if they wish to, like which type they want to return. But that would be part of your API design, and I'm sure that it's the kind of feature that is obvious when it's required, but if it's not required, you probably can safely ignore it. So I'm just going to check in. We've hit about an hour. What else can I talk about traits? I'm going to refer to some other documentation. And the doc that I would want to refer you to is called the reference. Now, I believe that you shouldn't feel intimidated by what is called the Rust reference. It's sort of a slightly informal, I'll change the screen, a slightly informal specification of the language. It isn't complete, but it's quite useful. And there's this good discussion about what a trait is. It's in fairly technical language, but it's very precise. And I think the precision is sometimes appreciated by people who are learning. So a trait describes an abstract interface that types can implement. Its role is to be an abstract base class or an interface. Where I think the reference is different than beginner material is the reference is going to tell you every possible thing you could do, even if you only require a very small amount of functionality. So Tim just asked a really good question around associated types. It turns out that you can also have associated constants. And we've got two types of methods that your traits are allowed to implement, which we've chatted about earlier. One, it has no default implementation, and another one does have a default implementation. In this case, it's empty. So this will do nothing. Trait functions are not allowed to be async or const. That's fine. If you are beginning, you don't need to worry about any of that. And you can have bounds as on the type parameters. That's useful too if you care. It turns out that traits are actually able to be parameterized over specific types, which means that you can create, in this case, a sequence trait, which has some sort of iterator object where f is of a function of t. So that's odd. I don't know. It seems like a strange example. So this is element at n, which is kind of okay. So we pull in, we've got this iteration thing where I return a function over f, but whatever. Cool, and there's some really technical material around a lot of the internal details of how these are implemented and what they mean. So if you're beginning, do not worry about all of it, but I want you to know that if you are beginning, if you want to understand more about how Rust works, the reference is a very good guide. Some other documentation I think is quite useful is I am a big fan of the Rust by example. So this is also inside the Getting Started with Rust. And inside here, we've got chapter 16 is traits. And it's a different definition, which is less precise, but hopefully, you know, it might be useful to other people. It's a collection of methods defined for some unknown type. That is a little bit too loose, actually. And I don't mean to be a Grinch here, but this definition is actually too loose. And the reason why that is, and I'll just blow that up other way around. I just made myself bigger so that I made the screen smaller. It's harder to read. I'm objecting to this, and here's a reason why. If I go back to the standard library, I'll pull this into one side, and then I'll go to the standard library on the left. I'm going to find you a trait. So one thing that we discovered, I want to hide this. How do I, here we go. And I'm going to talk about sync. So a sync trait, the sync trait has literally no methods at all. It is a so-called marker trait. Like its implementation is, we've got Esteban, who is quite common. He's on Twitter a lot, and he's known as the person who helps fix compiler error messages and make them nice. But if we ignore all the comments, what we've got here is sync is literally empty. There's only comments inside here. So so that's one reason in which a trait is too loose. By the way, the question mark is, well, what's the point of a trait that has literally no methods? And it turns out that it is just there to indicate to the type system about some property which matters to you as a programmer. In this case, it relates to the concurrency, the ability for you to share a reference across a thread boundary. But actually, there's no associated information. It doesn't exist, actually. There's no magical annotation on your type for implementing sync. It's just an assertion that you provide as a programmer to the compiler. Now, if that's complicated and you just lost a lot of that, and now I've just realized something really silly. And that is I'm not sharing the whole screen. Oh gosh, I feel really dumb. I wonder if I can, no, I cannot share too. I feel quite silly. I've just changed to a new software and I've just lost. Okay, so I'm going to change this. What is talking about? It's not relevant. Well, maybe it is. what I'm trying to say is that Rust by example has this assertion that a trait is a collection of methods, but we know that there are important traits where that's not the truth. And so that is all. Now, cool. Are there any other questions? I'm also happy to wrap up. I really appreciate people's participation and questions, and it's been really fun to hang out. But otherwise, if I receive nothing, I shall wave goodbye. It's like sort of like I feel like I'm like, we're 3, 2, 1. I'm going to say goodbye to everyone and good evening. I will also put some links around, and I really encourage you to connect with me. Say on Twitter is probably quite a good place. Feel free to ask me questions in the comments. I'll kind of try and check them, especially, but Twitter is probably where I'm most active. And sorry that this discussion has been a little bit all over the place. I hope it's been mostly useful. If you have any specific questions, ask them as well. I'll try and wrap all of this up as a tutorial that people can work through at their own time. And hopefully I can send that out to you later. Okay, take care. Bye-bye.